In chapter 2, we talked about the derivative, which is the slope of a tangent line at any given point on a curve. And the process of finding the derivative is called differentiation. So in this section, we are going to talk about the rules of differentiation. Now, first rule is that if c is a real number, then the derivative of c is equal to 0. So for example, the derivative of 5 is equal to 0. The derivative can also be given as f prime of x dy dx. We talked about its notation in chapter 2. Now next, if n is a real number and the function f of x is differentiable, then the derivative of x to the n is equal to n times x to the n minus 1. So take a look at what's happening. If I want to find the derivative of, let's say, x to the fourth, then the exponent 4 is going to come to the front and become a coefficient. So this will become 4 times x2. Now the power reduces by 1, so we have 4 minus 1, which is 3. So the derivative of x to the fourth would be 4x to the third. And we're going to be using this rule quite often in calculus and beyond. So for example, the first problem here says find the derivative of the function negative 3x to the fifth, and so on and so forth. So by the rules of differentiation, the 5 is going to come down. Now in this case, we have a negative 3, which the 5 is going to multiply with. Same thing with the 4. It's going to multiply with the 5. Same thing with the 2. It's going to multiply with the negative 9. And remember, the derivative of any constant is equal to 0. So if I simplify this, my f prime of x, or my derivative, is negative 3, and remember the 5 comes down, so negative 3 times 5, and then we subtract 1 from the exponent, so 5 minus 1. Same here, the 4 comes down, so we have 5 times 4, x to the 4 minus 1. The 2 comes down, so we have negative 9 times 2x to the 2 minus 1, and the derivative of 6 is just equal to 0. Now, I wrote this out the long way, but as we practice this more, we can just kind of do it mentally, right? So like 5 times negative 3 is negative 15, 5 minus 1 is 4, so we have negative 15x to the fourth. 4 times 5 is 20, you take away 1, we have x cubed. Negative 9 times 2 is negative 18, you take away 1, we have x. Then the derivative of 6 is going to be 0 because it is a constant. So that's f prime of x. Now, f prime of negative 1, let's first understand what this means. So f prime of negative 1 is going to be the slope of the tangent line at the point x equals to negative 1. So if we were to graph this curve and draw a tangent line, then that tangent line is going to have the following slope. So f prime of x represents the derivative. So f prime of negative 1 is going to be negative 15 times negative 1 to the fourth, plus 20 times negative 1 cubed, minus 18 times negative 1. And please feel free to use Desmos for this. And if you do, you'll get negative 17 as the answer. So the slope of the tangent line at x equals to negative 1 is negative 17. Okay, now let's go over some rules of exponents because we're going to be using those quite often as well. So let's say we have the nth root of x to the m. Then we can rewrite this as a fraction where the root becomes the denominator and the exponent becomes the numerator. So nth root of x to the m is equal to x to the m over n. Another rule of exponents is if you have x to the negative n, anytime you have a negative exponent, we can make it positive by moving it to the other side. So if it's on the numerator, move to the denominator. If it's on the denominator, move it to the numerator. So x to the negative n is equal to 1 over x to the n. Okay. Now on the flip side, if we have 1 over x to the n, so let's say sometimes we're going to have an exponent on the denominator, and we're going to want to move it to the numerator for differentiation. So anytime you move from the denominator to the numerator, or vice versa, the sign changes. So if we have 1 over x to the n, and you want to move that to the numerator, it becomes x to the negative n. Here's some examples. The fifth root of x cubed, the root becomes the denominator, the exponent becomes the numerator. That'll be x to the 3/5. X to the negative 3/5 is equal to 1 over x to the 3/5. And 1 over x cubed is equal to x to the negative third because we want to move this to the numerator, and when we do, the exponent changes signs. So here's the next problem. Find the derivative of f of x equals to x to the fifth root of f of x equals to the fifth root of x cubed. Now notice the directions here. Do not leave negative or fractional exponents in your answer. So in general, in calculus, we're going to convert all of our answers into only positive exponents, and all the fractional exponents we're going to convert back into roots like this. Okay, so we have f of x equals to x to the 3/5. Now by the rule that we learned in the previous slide, the exponent comes down and we subtract 1 from the exponent. So same thing happens here. The 3/5 comes down, which is the exponent, and we always subtract 1 from what the exponent is. So we have 3/5 minus 1. Now if you remember your rules of adding and subtracting fractions, we do need to have a common denominator. So the common denominator, if we have 3/5 minus 1, so this is like 1 over 1, the common denominator is going to be 5. And in order to convert the 1 over 1 into 5 over 5, or a denominator of 5, we're going to multiply both the top and bottom by 5, and this gives you 5/5. Which makes sense, right? Because 5/5 is in fact equal to 1, except now we wrote it with a denominator of 5. So we have 3/5 times x to the power of 3/5 minus 5/5, which is going to be 3/5 times x to the power of negative 2/5. Now we can't stop here because it says do not leave any negative or fractional exponents in your answer. So first we have to convert x to the negative 2/5 and rewrite this in terms of a positive exponent. So anytime an exponent's negative by this rule over here, we're going to move it to the other side and make it positive. So if it's a numerator, it goes to the denominator and vice versa. So we're going to put this on the denominator and we're going to rewrite it as 3/5 times 1 over x to the 2/5 according to this rule. Now, since 5 and x to the 2/5 are both on the denominator, we can just multiply those. So we have 3 over 5x to the 2/5. Now, in general, so I'm showing you guys what's going on, but as a shortcut, from now on, I'm going to be skipping this step and just taking the x to the negative 2/5 and moving it with the 5 on the denominator and going to this step here. But we can't leave our answer as a rational exponent. So in order to convert this back into a root form, the denominator is going to be the root and the exponent is going to be the numerator. So we have 3 over 5 times the fifth root of x squared. Okay, so the denominator is going to be the root and the numerator is going to be the exponent. And that's it. That is going to be our final answer. Okay, so here are some rules for derivatives. Anytime we have a fractional or rational, anytime you have a radical, we're going to rewrite that as a rational exponent, but then convert it back at the end. If anytime you have a variable on the denominator, we want to have it on the numerator so we can differentiate. So if you have 8 over x to the 5th, in order to move it to the numerator, we have to change the sign, so it becomes 8x to the negative 5th. In your final answer, do not include negative exponents or fractional or rational exponents. Rewrite these in radical form. So we have x to the negative 3/2. Notice it's a negative exponent, so it goes to the denominator. And we have to write this in radical form. So the denominator is going to be the root. Now for square roots, we don't have to write the 2. And the numerator is the exponent, so it becomes square root of x cubed. And then multiply or divide exponents if possible. So if you have x squared times x to the third, just make sure you multiply them. Follow the basic rules of exponents. All right, so let's take more examples. We want to find the derivative of negative 6 radical x plus 5x to the 6th. Now let's follow the rules here. Rule 1 says, rewrite any radicals as rational exponents. And then the second rule says, if you have or the third rule, second rule says if you have an exponent on the denominator, we move it to the numerator and change the sign. So if it's positive, it becomes negative once you move it to the numerator. And you'll see why we have to do this. So write all variables with rational exponents, and all the variables should be on the numerator. So we have negative 6x to the 1/2. So remember, this is like the square root and then x to the first. So that becomes 1/2 in rational exponent form. And the x to the 6th moves to the numerator with the 5, so it becomes 5x to the negative 6th. Then we follow our rules of differentiation. So we're going to multiply, so the 1/2 multiplies with the -6, and then we subtract 1 from 1/2. Same over here, the -6 is going to multiply with the 5. It's going to come down, multiply with the 5, the 1/2 multiplies with the -6, and then we subtract 1 from -6. So -6 times half is negative 3. The 1, I'm going to rewrite that as 2 over 2 to get a common denominator, and then we have -30 as the coefficient. -6 minus 1 is x to the -7th. So if I simplify this, 1/2 minus 2 over 2 is -1/2, minus 30x to the -7th. Now remember, we cannot have any negative exponents in our answer. So the x to the -1/2 has to move to the denominator. Write the final answer using positive exponents and radical form only. So the x to the -1/2 moves to the denominator, becomes x to the +1/2. The -3 stays on the numerator. The x to the -7th moves to the denominator, becomes positive. Okay, but finally, we can't have a rational exponent in our final answer. So we're going to convert that back into radical form, which is -3 over radical x minus 30 over x to the 7th. And please remember to come to class prepared with your questions. Okay, here's the next one. If f of x is 4x squared minus 3x plus 7, first find f prime of 2. Remember, f prime is going to be the slope of the tangent line at x equals 2. So this should be a pretty easy derivative. We have 4 times 2 is 8, and we subtract 1 from the exponent. Then here, the exponent for the x is a 1, so we're just going to have 1 multiplied by 3. Sorry. And then we subtract 1 minus 1, and then the derivative of any constant is 0, so the derivative of 7 is going to be 0. If I simplify this, I get 8x minus 3x to the 0 power, and then the plus 0, I'm not going to write that. Now recall that anything to the 0 power is equal to 1, so the x to the 0 is 1, which means I don't have to write that, and just becomes 8x minus 3. So this represents the slope of any tangent line at any given x. So since we want to find f prime of 2, that'll become 8 times 2, which is 16, and 16 minus 3 is 13. But that is just the slope. Now, we want to find the equation of the tangent line at the point 2, 17. Now, where do we get 17 from? Well, if x is 2, and you plug it into 4x squared minus 3x plus 7, we will get 17. Okay? So remember that the equation of any line is given to you as y equals to mx plus b. So the slope of the tangent line to f of x at x equals 2 is 13. That's our slope. We want the entire equation. So the entire equation is going to be given as y equals to 13x plus b, because the slope is 13. And then we're going to replace the x and y with the point 217. So the y is 17, the x is 2. And then if I simplify that, I get 17 equals to 26 plus b. Solve for b, and I get -9. So my equation of the tangent line is y equals to 13x minus 9. Okay, here's another problem, but this one will take a long time, well, a while, and my 15 minutes are almost up, so I will resume this problem in the next video.